Skinkis from the Department of Horticulture, and both Patty and James Osborne, who is from Food Science and Technology, work for the Extension Service and for the Oregon Wine Research Institute. And Patty will talk with us about grapevine management, about canopy cover, about that maybe surprising statistic about why trimming the harvest, trimming the crop in the middle of the year is so expensive. She has a viticulture course online that you can take from home if you like, or if you're close by, you can go to the campus, but you can do online. She also has YouTube videos that describe various techniques, pruning techniques, rust mite monitoring. In her own research, she has documented the benefits of managing canopies and cover crops for vine growth and grape quality. She has her Ph.D. from Purdue University in 2006. And James Osborne will follow her. James is studies wine microbiology, and he teaches classes on wine production and analysis. He focuses on the interactions among microbes in the fermentation process and what happens when wines, they're going well and they're going not so well. James has his Ph.D. from Washington State University in 2005, and at the end of his presentation, or close to the end, he will be sharing some samples with you to sniff, to smell, to get a sense of what are some of the off odors that you might detect if things aren't going so well. So, Patty?
Well, thank you for inviting me to talk about one of the things that I love to talk about the most, and that's the grapevine. And I know when Nick first came to us to talk about whether I could give a presentation, I said, well, I can't possibly present without my dynamic duo, James Osborne, to talk about wine, because I am first and foremost a horticulturist, and I love talking about whole plant physiology and grapevine growth. And one of the things I'm going to talk about tonight is understanding vine physiology in the grand scheme of things in production in Oregon. We have a lot of different challenges than other growing regions, and some of you who grow grapes, you might know some of those quite well. So the Oregon wine industry is a relatively small industry. Of course, you just went through the trivia. We only have an average size of our wineries of 5,000 cases. That's not very many. The average size of wineries across the state, or of vineyards across the state, is only about 20 acres on average. We do have some bigger players up to 1,200 acres, but for the most part, on average, we're about 20 acres per vineyard, and our total is 20,500 acres total. About 600 or 60% is Pinot Noir. No matter what part of the state you go to, it's actually the #1 variety that's grown in those other parts of the state. Yet some of those areas tend to boast other varieties. So we've got an industry down in southern Oregon. Many of you are aware of the Willamette Valley. We produce about 72% of the total acreage. You go down to southern Oregon, there's a lot of Pinot Noir that's produced, and in years like this, when it's really cool, all of the Willamette Valley growers want to get fruit from down there where they can get a little bit more ripe. So we are producing Pinot Noir in southern Oregon as well as some warm varieties. We also produce over in the Columbia Gorge and in eastern Oregon. So there's Pinot Noir in each of those regions, but they also boast some of our bigger reds that we can't produce here in the Willamette Valley. On average, we have about 30,000 tons of grapes coming in, so that hit, that's a general level that we're producing at. So that hit on the trivia earlier, where we're up to 40,000 tons was one of our maximum to date. And that's probably going to start increasing, because in 2007, we had a massive increase of amount of acres that were planted. The value is about $77 million for wine production, and this all comes from about 849 vineyards and 315 wineries. So this is a very small industry when we consider the total amount of businesses involved in our small industry. So here's a display of the acreage and how it's increased since 1994, and as you can see here, I have the total grape acreage, and Pinot Noir being about 60% of it. So it's still holding pretty strong. In and around 05, 06, 07, there was a major increase in the amount of total acreage that was going in. A lot of people were needing more Pinot Noir to meet their demands in their winery. And we see that in about 2008, 2009, right when the recession hit, it kind of leveled off. But recently, it's been increasing. So we still see a bit of slowdown in the grape plantings, and Pinot Noir is still holding very strong as our flagship variety for Oregon. So as a statewide specialist at Oregon State University, I conduct applied research as well as doing my extension. And as a statewide specialist, I really try to hit the target for a lot of grape producers around the state. So not just here in the Willamette Valley. And I try to focus on what is considered the major challenges. And if you look across the state, we know that there's Pinot Noir being produced in all areas. There's definitely a difference when we think about climates across the state. But one of the things that is critical and one of the commonalities across all of them is our vigor management. We have really high vigor vines. There's different ways to manage that vigor depending on the parts of the state that you're in. But in general, no matter what area of the state you go to and you ask vineyard managers what their number one concern is, they'll say managing their vine vigor. It's too high. And also, as a part of dealing with that is the economics. So the economics are twofold. They're high. It's very costly to produce grapes because of the type of grape production we do. Premium wine production means premium grape production in the vineyard. It also has to do with our cool climate. We tend to have lower yields, not because we're not setting them. The vines can carry quite a bit, but we're reducing the crop level so that we can reach a balance. And when we talk about vine balance, that's a central theme in viticulture where we need to have a certain amount of canopy to support a certain amount of fruit. So we need that photosynthetic development for the sugars and ripening of the fruit that's there. So if we have a cooler season, less sunlight, and less heat units, we need more of that canopy to provide for the grapes, or so we think. And this is in comparison to other parts of the state or down in California. So when it comes to vineyard management, we have very high production costs that I'll go through in a couple of minutes. And I want to see a raise of hand. How many people think that Oregon wines are quite pricey? So they're quite pricey for a number of reasons. Of course, they're exceptional wines. But also another reason is the very high cost of just producing the grapes here in the state. So those are two things that I focus on when I design a lot of my research projects to try to hit at those two things. And if you look at these vineyards right here, how many of you have seen vineyards that look like this? More than likely, a lot of you have seen the nicely trimmed ones with very neat and tidy hedgerows. And this is actually what they look like before you go in and give them their haircut. So they've got lots of laterals growing and lots of shoots. They need to be managed to get that sunlight in there and get good exposure of both the fruit and the rest of the canopy. So here's another example of a vineyard after it's already been hedged. And grapevines will grow like crazy. As those of you who grow them, you know they'll just grow like weeds. And we're trying to conform them to this beautiful system of vertically shoot position canopy. We get them to grow and produce a nice wall. We want them nicely exposed. We've got to come in and remove all of this. So then it looks like this after they run a hedger through. So it looks beautiful now. And one doesn't realize just how much that extra growth is shading their vineyard. And this is in August, and they've already gone through, and they have to do every other row with the hedger. And then you can see ones that have not been hedged yet. So that's how much overlap, just that's from the same vineyard that I had those other pictures from. It's reducing the sunlight infiltration into the canopy by that much if you don't do hedging. So as you can imagine, if you've got a very vigorous vineyard, you're going to have more and more of this growth when you're trying to confine it to a training system that's really developed for a moderate or low vigor vine. We've put them big, vigorous vines on these training systems. Many of the vineyard managers here in the Willamette Valley have to go in and hedge anywhere from 3 to 5 times during the season. So that has some cost to it, but that's not the only cost that is involved. Of course, I'm not going to get into nitty-gritty details, but doing all of that hedging can have some implications on vine physiology by removing growing points, growing points of the vine, and has probably a cascade event of hormones and how that is responding, how the vines are responding to those hedgings. So one of the things we've noticed over the last 20 years or so is that Oregon vineyards have changed the way that they've been designed. So back in the 1980s, they were wider spacings, different training systems. They were really designed for, probably more adequately designed for high vigor vines. As we've come into the 1990s, we've had them switch over to what I call more trendy vineyard management. And they're looking more towards Bordeaux, looking more towards France as to what they are doing. So they're not only putting it on these vertically shoot positioned canopies, but they're putting them at very narrow spacings, both in row and in the vine row. So within the row and between the row. And what that does is it requires that each vine then has a smaller amount of space and fewer buds are put out. Fewer buds, but would lead to more vigor into the buds that remain, therefore more shoot growth. And we have relatively unlimited soil moisture and soil depth. So by planting them close, they're really not competing with each other. Initially, I think they all thought that they would have competition and they would be able to bring down the vine vigor. But what we have is this. We have excessive lateral growth. So not only are they growing up, but they're growing out. And extremely dense canopies. It's also led to some vineyards starting to actually have over-vigorous problems where they're not setting enough fruit because of it. So there's a lot of this situation occurring with those high-density plantings. So knowing that we have high vigor, that creates more of a problem with our already high vineyard management costs. So premium wines really have to come from premium fruit. So even if we were in a vineyard region where we can control our vine vigor, we would still have a high management cost. When I show this slide to other production regions such as California and Washington, they almost keel over. The cost of canopy management alone, this is not harvest, this is not any other factors in canopy in managing a vineyard. This is just managing the canopy from shoot thinning, shoot positioning, hedging, leaf removal, and crop thinning. This doesn't even include pruning. It's about $1,500 to $1,600 per acre. To crop thin, the one question that came across today, that's $540 per acre for a vineyard management company or vineyard manager to go through and do that. In comparison, dormant pruning is about $450 per acre. Harvest is a mere $250 per acre. So all these add up to over about $5,000 to $5,500 per acre to manage premium Pinot Noir here in the Willamette Valley. And that's just talking on a moderate spaced vineyard. Once you add more vines, the cost goes up from there. So the fruit is expensive to produce. It's expensive for a winery to buy. And then once you do the production of the wine, it leads to the necessity to bring home a higher dollar per bottle on the wine itself. So looking at this cost of management, when I look at this from a research perspective, I will look at what the vineyard managers really want to address. And some of their concerns are over the most costly thing, crop thinning, and just overall vigor management. If they can reduce the vine vigor, they could cut down on all these management practices. And the question becomes, once we're thinking about managing a canopy, is the question of, is it physiology that we're impacting, or is it simply the microclimate of the fruit in this matrix of a canopy? So a lot of times what vineyard managers are doing is what I call vineyard liposuction. And it's because our high-end wine industry, we've got big vines, they're growing like crazy, we've got lots of resources for them. They're going in, they're cutting off leaves, they're cutting off shoot tips, they're removing shoots, they're cutting off fruit. So that's what I call making a modification of the microclimate. It's really not changing the internal physiology of that plant to now act like a more stressed vine, one that's going to perhaps result in a higher fruit quality. Because how many of you have heard that stressed vines make better wine? Or weak vines? Yeah, so that's a relatively simplified statement of the fact that in general, as plants are stressed, they will produce some secondary metabolites that we enjoy as consumers. Certainly, we have to find that happy medium when we're talking about managing a vineyard. Certainly, we want to have happy vines, but we want to figure out what is the physiology that we need that will create the microclimate that we need. So we need to really hit home with managing that vine vigor. So ways that we could do this in the Willamette Valley are really limited. We have so much soil moisture. We have really deep, rather deep soils. We can't really control our vine size by irrigation because we really don't get a deficit of soil moisture or water stress during the growing season. So one of the things that we do have to our disposal is lots of grass that grows really well. So we're looking at using permanent cover crops to manipulate the vine vigor and how it might influence fruit quality. And I work with a collaborator over in Food Science Department, Michael Chen, who's done this work alongside me for the last 4 years. We've done this vineyard study where we've looked at clean cultivation, where we basically remove all of the cover crop. We leave it clean cultivated between the rows, hoping that we wouldn't have any competition for water or nutrients. And then we have alternate row tillage, where it's either alternating tillage and grass cover, or we're using permanent grass cover. Basically to pull out, in the initially we thought would pull out extra water or nutrients. And what we've found is that it's not really reducing the amount of water to the vine, it's reducing nitrogen, which is a key factor in that vigor. So everybody knows that you give plants nitrogen, they'll grow like crazy. We actually have not fertilized these vines in the last 4 years. We've just used the grass as a way to pull out extra nitrogen from the soil. Each year nitrogen will cycle out. We're pulling it out, and the vines that have the clean cultivation between them have remained at a higher level of vigor. So it might be a little bit difficult to see here, but this is a picture of this trial at just after harvest. These vines right here are in that cultivated treatment where they have not had the competitive cover crop, and they are still green. And this is about the 20th of October. And the ones that have had the grass cover are much more yellow. They're shutting down earlier. They're not stressed, they're not water stressed, but they're just nitrogen stressed. Their canopies are smaller, their vine size is smaller. So there's the perennial grass cover, and there's the cultivated alleyway vines. And what we found over the 4 years of the study was that ripening did not differ. We were still able to get that fruit ripe, which meant that we still had the vine balance there. But we noticed that the permanent grass cover was competitive enough that we reduced the vine size, and we had higher concentrations of fruity and floral aromas that we wanted. And we also increased the phenolics. We did have lower must nitrogen, and that can be a critical concern for our industry, because if you don't have enough nitrogen, sometimes the fermentations won't go through, and they'll have what's called a stuck fermentation. And when we had a sensory panel from wines that we made in 2010, the grower and winemaker panel chose the grass cover as the most preferred wine in the sensory, compared to the clean cultivated, which had bigger vines, and they had more of these green aromas, which are hexanols or hexanals or hexanols, which tend to impart a more underripe flavor. So while they both had similar sugar levels and acids, we are finding that the cover crop and the nitrogen component plays somehow into the sensory and composition of the fruit to make a better wine. So we've noticed that the cover crop management has been a key tool for a lot of vineyards, and so that's one aspect of the research that I've done. I've also looked at ways that early season leaf removal could be used to help growers, because one of the things that another key cost of production is disease management. And certainly disease management plays directly into the result of the fruit quality. So a lot of times we think of fruit quality as being what's the composition of sugars, flavors, but one of the first and foremost is whether we've got diseased fruit. Leaf pulling is a very common practice that is used here. It's one of those methods to basically take take the canopy that you have and modify that microclimate, make sure that the fruit is well exposed. But one of the things that I was suggesting was go in, do it extensively in the canopy to remove all the leaves from the cluster zone, get that exposed early so that you could reduce your sprays, your pesticide sprays, and get better coverage. And in doing so, we thought perhaps we could also decrease the amount of fruit per cluster, make smaller cluster size, and hopefully reduce crop thinning. That didn't work completely to reduce a canopy size or a cluster size, but basically we were able to reduce disease, we were able to slightly affect fruit set, and we are still looking at the possibility of increasing the fruit quality. So this is the concept that we used. Here is a very young vine, early in the season or before bloom. You can see here's the inflorescence. And what we did was we went in and pulled all those leaves off. So pretty much all that's left is that growing shoot tip and one nearly expanded leaf. And as most of you probably know, a flower that's still forming needs carbohydrates to continue its development and actually go through bloom. So we wanted to do this early enough that we're removing all that carbon source. We're also getting, when we go in with a fungicide spray, it's going to get right into that cluster and keep it protected from any of the powdery mildew or botrytis, which are the two main important diseases for the Oregon industry. And hopefully we would also impact fruit set because it's one of the most expensive things that we do in a vineyard. We remove 50% of the crop some years. So the goal was that if we can take, here's a very close-up of a inflorescence of a grape cluster, and as we move into bloom, this is a fully blooming cluster of grapes, we notice that there's parts of the flower that actually come off and stay a lot of times within the cluster. Those are primary sites for infection by botrytis. And if you don't get into your vineyard and manage for botrytis with a protective fungicide spray or knock those pieces of tissue out of the cluster by either a water spray, air spray, you may get botrytis infection that early, and it can stay trapped or latent until later in the season. So we wanted to be able to open up the canopy, get those out, and get good spray coverage. And so this is actually what it looks like in the vineyard when we remove the leaves at our earliest timing. We actually did this at a number of stages, starting at pre-bloom, bloom, at fruit set, and then again at pea size, and then at bunch closure. So all during different stages to see which one would be the most effective in either reducing canopy or reducing disease or reducing fruit set. And during the 3 years that we've done this trial, we've actually not impacted fruit set to the level that we would lose our entire crop. When I first started this project, a lot of the growers said, you can't pull leaves before bloom. I said, sure you can. They're like, no, you cannot pull leaves before bloom. I said, well, this is science. We always need to bookend it. We'll start really early. We'll figure it out. So they were amazed when I first started doing this in the growing season of 2008, which was a late, cool season. I pulled leaves. We didn't affect fruit set at all that year. In fact, the first year that we've noticed some influence on fruit set was in the cool season of 2010 and then again in this cool season of 2011. But it was really a very minor shift in the amount of fruit set. We still were able to get adequate crop there that they still needed to crop thin. So here's an example of the leaf pulling at harvest. We have this nice open cluster zone. And basically, we also wanted to quantify the amount of botrytis that occurred, and this was a great project to do during the last 2 growing seasons. We had a very cool season. A lot of people had, whether they did the best of management in the bloom time period, which is the critical time period, they were still finding a lot of botrytis in fall of 2010 and fall of 2011 simply because we had so much rainfall during parts of the ripening period. So here's botrytis in particular. This study, we do look at both infection of powdery mildew and botrytis. In all years, the leaf pulling did help reduce powdery mildew infection, but a lot of times the control was so good to begin with in a vineyard, it wasn't much of a difference that we could detect. All of these trials were done in commercial vineyards where they're making efforts to control, and we look at our management practice differences amongst their normal controls. So this is what we were looking for at the end of the growing season for Botrytis. So this is one of the few things that I was going to show for data. If we look here, this is the incidence of Botrytis in a cluster in 2010. We're still processing data from 2011 because we didn't harvest until the end of October, almost the beginning of November. But this is the incidence. And if we started earlier season, and pretty much if we picked off the leaves or did cluster zone leaf removal, it helped reduce our total amount of Botrytis versus if we left those leaves on there. So it was pretty telling. And we also were noticing that early season, we were affecting the number of berries per cluster that was setting. There was a minor impact on reducing fruit set to some degree with those earlier leaf pulling. So we had a more open cluster when we have fewer berries per cluster. In 2010 at harvest, this shows the severity. So we noticed that there was a reduction in the incidence, so how much Botrytis, or whether it existed or not. And this is more about how much of the Botrytis. So in one of our sites that's later, and the pink is a later site. It's about 2 weeks earlier or later than the red bars, and that one had the major impact. So the later you shift to harvest later in the season, having pulled leaves is more critical simply because you're getting into that window of time where you have rainfall to be worried about. So this really shows a lot of the growers that pulling leaves alone and keeping their normal management practices going could help them significantly reduce their disease infection. So earlier season to later in the season, it didn't really matter too much as long as it was pulled before bunch closure, which is basically when the berries start to touch. And what we found was that the fruit composition was not really reduced by early or intense leaf removal. A lot of people thought that they wouldn't ripen their fruit because you've got the sugars that might need to be coming from those basal leaves, but those basal leaves are not the most efficient as you get into the later season. It's the ones that are mid-canopy or higher that are most efficient. So we didn't have any differences in total anthocyanins, phenolics, sugars, acids, or pH. We are still looking at the impact of this trial on specific anthocyanins, and also another study that I'm doing with leaf removal basically showed that we are increasing our total amount of our aromatic compounds when we're doing 100% leaf removal or 50% leaf removal in the canopy. By leaving them there, leaving leaves there is reducing the amount of more mature characteristics in the fruit. And this is what it looks like in practice. This is a Scott Henry system. One of the vineyard managers went through and removed leaves early in the season, right after about fruit set or when they're at the pea-size stage. And a lot of industry has implemented this practice over the last couple of years. And because our climate is so cool and the sunlight is not very intense, we don't often have sunburning. And a lot of people always ask about that. Are we going to sunburn our fruit? And the answer should be no, as long as you're leaf pulling well before veraison or the beginning of ripening. If you pull at veraison, you'll almost always be guaranteed to have sunburn. And it's because they still are producing some of the photoprotective compounds when you're leaf pulling well in advance of the beginning of ripening. And the next step is, can we effectively mechanize this early season leaf pulling? A number of people have, probably 50% of the producers here do have mechanical leaf pullers, not this fancy machine exactly. We only have about 3 of those in the state. But we want to know if we can leaf pull early mechanically so that we wouldn't have to run through crews at a time where we normally wouldn't be doing it, and without damaging those really small inflorescences. So we've started that actually in this 2010 growing season at one vineyard where they have an over-the-row mechanical leaf puller, and we found that depending on the settings, you can do it very early without damaging any of the fruit. So moving along, I wanted to talk a bit about the crop thinning. So I talked about removing leaves, about reducing vine vigor, and now I wanted to address one of the biggest questions that the Oregon industry has is, what crop level do we need in order to produce really quality fruit? Over the last 15 years in Oregon, there's been a reported average tonnage per acre, and does anybody want to guess what it is? Tons per acre? 2. Everybody who thinks 2, that's absolutely correct. It's on average 2 tons per acre. And that's not because the vines only produce that much. It's because that's what we're telling them to produce. We're going there, we're removing crop, and that really is one of our only quality metrics for grapes thus far. People have in their contracts 2 tons per acre, X amount of bricks, this is what we need. And we question whether that is actually what we need to be having, especially when production costs are so high and when you could be potentially growing more. So basically, crop thinning does a couple of things for us. It reduces crowding within the canopy. So anytime you have overlapping clusters, that's a potential for disease. So some people may choose to crop thin for that alone. Other times they're doing it for a quality parameter to reach a tonnage in their contract. But there can be ramifications of different timing or the effect on different cultivars what crop thinning may do. So when we look at crop thinning, it really can change that vine balance, how much fruit we have versus the amount of canopy. Timing, if you do it really early, can potentially impact your fruit set. There can be some impacts on berry size and also impacts on cluster compactness. So how many berries in that cluster can impact that cluster compactness. So those have multiple ramifications, disease-wise, fruit quality-wise. And as I mentioned before, this practice costs about $540 per acre because sometimes vineyard managers will go through, they'll thin, they'll realize they have too much crop still out there, they'll go on through again. This is a year where they've gone through probably 3 times or more to crop thin. They've gone through in their first pass, second pass, third pass, weighing clusters, finding out they're too heavy, they're going to reach more than 2 tons, they need to drop it down. And it becomes very frustrating for a vineyard manager when they see stuff like this on the ground. And a lot of them are doing it at lag phase, which is just before ripening or later. So we went in and we've got a number of experiments going on, and we're trying to look at different timing and intensity of crop thinning. And this was great because we did this during 2 of our coolest seasons in Oregon since I've been here, 2010 and 2011. And what we found in both years is that there are not very many differences. In 2010, we had no difference in anything we measured, whether it was vine size, whether it was fruit quality, nothing was different. However, we only had an average unamended crop of 3.5 tons per acre, even on a very high density vineyard. This year we have on a moderate density vineyard that we're using for this study, we have about 6.5 tons unamended. So we have a range from 6.5 down to 1.5 tons. And with our crop thinning, we've done a 50% and a 25% of total crop. And we're going to hopefully see some differences in fruit quality, but it's actually not looking like we have that much difference. The vines are large enough here that I'm starting to think that one of our biggest limitations is actually our season, not our canopy size. So we'll have more details coming from that work in the near future. We've also started some studies within varying vine vigor levels, what kind of crop we need to hang, and what kind of fruit quality we have from that. And in this study, it's immensely popular. We have a lot of growers throughout the state that are going to participate in this study on a large statewide scale in the future, and James is going to help out with some of that project. And I just want to wrap up with one more study that I've done. I've talked about different ways in which we can manipulate canopies on more established vineyards. And this is a project that we started with smaller, younger vines and how we could use cover crops in a way that could be a sustainable or organic option for establishing vineyards without herbicides and without fertilizers. So we started with young vines, and we grew a cover crop of crimson clover and rye and used the biomass as a mulch in the vine row. And we've looked at everything from soil moisture, vine growth, root density, vine nutrition, and this is actually our first year we've brought home a crop from it. This was year 1, and this is the beginning of year 3, beginning of this summer. You can see the mulch here in the vine row. And this is at the end of the season. We actually brought in, I think on average, we had about 3.5 tons of fruit off of this 3-year-old vineyard. This is a Chardonnay vineyard, and we're going to look at a lot of different quality components. We've noticed that by using this mulching method, we've been able to decrease weed growth, which is no surprise to anybody who uses mulching in their garden. It decreases compaction on this more of a valley floor soil, which tends to compact very easily. It's increased vine biomass, both in terms of its root biomass as well as its total canopy. We've increased chlorophyll, as well as increased our yields. There's more inflorescences per vine and more clusters per vine in this study, which really begs to indicate that we had some major impacts on the amount of nitrogen in the vine itself, just from this cover crop of crimson clover and rye. So a lot of the work that I do could not be done without the support and collaboration of a lot of vineyards and wineries throughout the state. I currently have about 10 research sites that I work with. That's how many research sites I brought harvest in from this year. And a lot of these people are actively involved in our research and our extension programs. And this is Bill Wendover from Stonefield Vineyard and Ted Gerber from Forest Winery, both in Southern Oregon and collaborators of mine. So any questions? Yep. That's an excellent question. The 2 tons per acre, where did that come from? Basically, I believe it probably comes from some of the vineyard production back in the 80s. So when you look at in the 80s, they had maybe 454 vines per acre, and when you put that few vines per acre and you have that spacing, that's about a 10 by 12 spacing for a vine. You put out that many buds. For a Pinot Noir, that's probably all it could manage to grow. And at that amount, you'd only get 2 tons per acre, even if you didn't crop thin. So then they kind of figured, well, that's our production mark. We need to have 2 tons based on that. But over the years, we've more than tripled, if not quadrupled, the amount of vines per acre, and we've not quadrupled the tonnage per acre in the process. So I think that's part of it, just because the industry kind of got going, and that's what the sweet spot was, but they didn't take into account some of those other factors. I've heard some producers say, well, if it's good at 2 tons at a moderate spacing of 5 by 7, it should be great at a meter by meter 5 spacing at 2 tons. And I'm thinking, I'm doing the math and the economics in my head. I'm like, this is not great. So, yeah, that's partly where it comes from. Yep. So the question was, what about vineyards that don't do sprays, and do you see a benefit of the leaf pulling? Actually, 2 of the vineyard sites that I used for the leaf pulling study were actually organically managed. Organically managed does not mean no spray. There's no vineyard that uses absolutely no spray. They just use organically certified sprays. So they're using things like sulfur. The majority of our industry is actually using a very heavily organic product spray program, largely because it's cheap. They use sulfur for a lot of their powdery mildew spray program. So certainly if a vineyard has its adequate spray program, leaf pulling will certainly decrease the amount that they'll see even still, because every vineyard will get some powdery mildew and some botrytis, and it certainly has reduced it. The nice thing about doing this project in a commercial vineyard is we won't get massive differences like in a study where we wouldn't control with spray, but we're seeing differences even in a managed vineyard, so it certainly does help. So the question was, are there certain varieties that can handle more of the botrytis? Is that what you're asking? Yes, I was only looking at Pinot Noir. Mm-hmm. Yep.
Hold the quality of the wine the same between Oregon, Washington, and California? What are the production costs? What are the relative costs between California, Oregon, and Washington?
So the question was, what are the relative production costs between California, Washington, and Oregon if we consider that the quality is the same? That's a great question. It probably would be still higher here simply because California and Washington the different cultivars can produce heavier crops. Pinot Noir, relatively small cluster, so their yields are smaller. Also, there's only so much you can produce per acre, so it comes down to yield and total inputs. And certainly we have a lower yield and we have more inputs. So either way, even still, we would have a higher one. I don't exactly know the costs of production, but I would imagine that they're probably 50% or less.
So do I overpay for an Oregon Pinot Noir?
Well, that depends on what you like, but basically, either way, it costs more to produce grapes here in Oregon. So, yeah, it's up to what you prefer. Certainly, and I would like to believe that Oregon Pinot Noir is some of the best in the nation. Are we okay with? Okay. What's an acre of Pinot Noir worth in terms of the established vineyard or of the fruit? So the fruit generally is anywhere from $2,300 per ton, and if you have 2 tons per acre, it's about $4,600 per acre. It can be anywhere up from that. Very high premium vineyards can take home much more per ton of fruit. A lot of people now are changing to acreage contracts rather than tonnage contracts because they know they're dropping crop to meet a metric, and so it can be. Usually, I would say $2,500 per ton, or $4,600 to $5,000 per acre, just for the fruit. Yep. Okay. So I'm going to hand it off to James at this point.
I just thought they turned up at my winery door and I made wine with them. Sometimes that is the case. But I'm going to talk a little bit about winemaking, and particularly about the microbiology of winemaking. That's where my background all is in, and that's kind of what I love, is little microbes who are doing things. And so my talk is kind of, I titled it Rotting Grapes to Perfection, because really, when we're talking about winemaking, it's kind of all you need is a bucket, some grapes, and your feet to stomp it, and then you just let stuff happen. And the rotting grapes part's real easy. The to perfection part, that takes a lifetime of skill, I think. So we're going to cover a little bit of stuff. I want to just introduce where I'm from. I speak a little funny, so in case you were wondering, I don't come from around here. I grew up in Auckland, not Oakland. A lot of times when I say Auckland, people think I'm saying Oakland. This is not Oakland. This is Auckland. Actually, this is Taranaki. But I grew up on a dairy farm. I grew up milking cows all my life, so I really didn't have much to do with wine or beer or anything like that, actually. And it was actually through schooling that I kind of came to fall in love with wine and the winemaking process. So I went to school. Oh, this was just in case you're wondering where New Zealand is, if you've never seen the map. Right up here at the top of the world, that's where you'll find New Zealand. Don't be confused by any other maps you may have seen. America's down here somewhere. And the other thing I always point out when I show this map, there is no bridge between New Zealand and Australia, nor is there a tunnel between New Zealand and Australia. Someone has asked me before if there's a tunnel between New Zealand and Australia. That would be a very long tunnel. That's about a 3-hour flight on an airplane. So we're close to Australia. We're not a suburb of Australia. We're not part of Australia. I've been in the US long enough, and people always think it's funny to pretend that I'm an Australian. I don't have anything against Australians, but that's not where I'm from. So I got into microbiology when I was in school, when I was in the university, and through that kind of led me to wine. When I studied micro, it kind of really fascinated me what they can do on the beneficial side of things. I took a few medical microbiology classes and it didn't seem like a very cool thing to study. It was pretty gross. Soil microbiology was where I started off, and then learning how you could use microbes to make cheese and bread and wine and beer and all of these great products. It seemed like a really fun thing to study. And so I stuck with that all the way through to my Ph.D., studying how microbiology can be utilized in the winemaking process. So these are a couple of my friends here. This is a little bacteria. This is actually an electron microscope of it. So they're tiny, tiny, tiny. And this is some yeast over here. And these are kind of the two microbes that I've been studying for most of my academic career. So from there, I eventually make my way to Oregon. I spent a bit of time up in Washington State, up in Pullman, Washington. So go Cougs. I'm now, I suppose, a beaver. I was telling someone the other day, I feel like I'm in a bit of a gray area right now. The Cougs aren't very good at football, and I've been away from that school for a while, but I'm not yet fully converted over to being an Oregon State Beaver, so a little bit of apathy there on the football team. I think if Oregon State was winning a lot more, I think I'd be on that bandwagon, but we'll see how we go. So I've been in Oregon for 6 years now. I really enjoy the area, and I really enjoy the Oregon wine industry. I think it's a really neat industry. A lot of family-owned wineries, a lot of family-owned businesses, and it's a really neat environment. We do have the third most wineries in the U.S., behind obviously California and then Washington, and about the fourth most in production. Upstate New York, or New York, kind of slips in there on a production level, but they have a lot of from a grape production level, they have a lot of other grapes that not necessarily used for premium wines. So Oregon's about third in wineries and about fourth in production. Now we're small, you probably know we're small, and when you put it in the context of California, you realize how small. California accounts for over 90% of the U.S. wine production, probably closer to 95%. And so the only way that the Oregon industry survives is quality, premium quality wines, because we can't mass produce huge amounts of $5 wines at an economic level. We've heard a lot about how hard it is to grow grapes in Oregon and how hard it is to grow quality grapes. So the scale of economy thing doesn't work very well for us. Luckily, we can do some Pinot Noir style wine very, very well, and that's how we survive. Patty's already mentioned this, that most of it is Pinot Noir, and she gave a number on the amount of wineries. 319, I think, was the number that Patty showed. That's wineries, what we call brick and mortar wineries, actually physical wineries. There's more than that if you count what we call virtual wineries. So this is where if you wanted to have your own winery, but you didn't have the resources, you could take your grapes or buy some grapes and get them what we call custom crushed, custom made at a different winery. And so those, you have your own winery license, and that kind of counts in this number. So these numbers are often quoted, and we've heard this as part of our quiz. I like to talk about this number, 1.9 million total cases. There's a winery down in California you might have heard of called Gallo. You may have come across their wines. They produce over 70 million cases of wine. In fact, they have some tanks down there in Gallo. All of Oregon's production in a year could fit into 2 of their tanks. So we're not competing with them anytime soon on size. I played this little game with my class the other day, winery or refinery. Which of these pictures is the Gallo winery and which is an oil refinery? This is the Modesto winery down in Gallo. This is one of their tank farms. This is an oil refinery. So scale-wise, it's a different world up here. We're definitely focusing on that small scale and on that high quality. So Pinot Noir winemaking, we've heard a bit about all of the effort that goes into making these high-quality grape clusters that can then be delivered to the winery and produce high-quality wine. You can't make great wine without great grapes, but you can make some pretty lousy wine with great grapes. So there's a lot can go wrong in the winery, and a lot of times you'll talk to winemakers and they'll mention they're really just trying to steward that grape through the process, do no damage, kind of let the grape express itself, if you want a winemaker speak. So there are some challenges, though, with Pinot Noir that come along. In general, there's less, we're not so affected in the winery as far as climate goes. Winemaking in Oregon is not super different to winemaking in other parts of the world, but Pinot Noir does present some challenges, and certainly from a winemaker's point of view, you probably spend as much more time than any other grape in the winery on Pinot Noir. It's kind of the problem child, but it's worth it in the end. The two things that we're often worried about or focused on in winemaking with Pinot Noir are the aromatics, so how it smells, and focusing on some of those components. So these are some terms that you might read on the back of a wine label. Floral and fruity aromas. There's some specific ones related to Pinot Noir that a winemaker will go to a lot of trouble to preserve from the grapes or enhance during that winemaking process. So we have cherry and raspberry and blackberry, currant, violet, rose, all these floral and fruity terms that often can be expressed in the Pinot Noir wine. Then you have some aged aromas, mushroomy, truffle, leather, spicy. These are all part of what a Pinot Noir can smell and taste like, and some of them are contributed by microbes, some of them contributed by the grapes, and some of them contributed to just aging in oak barrels, for example. It all kind of combines to give you some of these lovely aromatics. The other part of the process that winemakers spend a lot of time working on is the mouthfeel of a wine, or the texture of a wine. So that in Pinot Noir is probably its most valuable quality. The really high-end Pinot Noirs hopefully have amazing mouthfeel, amazing texture and structure. What you don't want in your wine is something that's described as drying, rough, green, or bitter. Those are all terms that are describing a negative side of texture, a negative side of mouthfeel. So if you've ever had a wine, maybe it was a cheap wine, that was really, really astringent, really rough in the mouth and drying and just not very nice at all, and even may have left a bitter taste in the back of your mouth. That's coming from these compounds called tannins that are in the grapes naturally. And in high-quality grapes, hopefully they're tending to give you wines that are using these descriptors, such as soft or silky or round. That's the goal, the aim of producing high-quality Pinot Noir, is having wines that have these descriptors associated with them and not these. And so in the winery, there are some tools of the trade, there are some techniques that you can employ to try and get these sort of mouthfeel characteristics and avoid some of these. So that's where there's a lot of effort goes in. One of the quiz questions was about seeds and whole berries versus crushed berries. And winemakers in Oregon go to a lot of trouble to try and get as many whole berries in the fermenter as possible. And a lot of that is to do with minimizing the contact of seeds with the wine. So when a whole berry is fermenting, that seed is enclosed in the flesh for much longer and is less exposed to the wine around it. What happens is that if that seed is exposed in the wine, some of these tannins in that seed are extracted. The tannins are ethanol soluble, so they're extracted out of the seed. And some of those seed tannins can give bitterness, can give some of this drying roughness in the mouth. So these whole berries, the winemakers feel, you minimize that seed contact. You don't get as much seed tannin in your wine, and you maximize maybe the content coming from the skin, and so therefore hopefully getting this rounded, kind of smooth, silky mouthfeel. So that's one of the techniques that winemakers use. There's a whole bunch of others. I think Pinot Noir has the most variation when it comes to winemaking compared to some other wines. The other thing that can be sometimes problematic in Pinot Noir is the whole microbial process. So that's where I kind of get excited. That's where what I'm interested in. I've kind of broken it down here real simple. Grapes over here that turn up at the doorstep. They have a whole lot of stuff in them, sugars, acids, flavor and aroma compounds, as well as the phenolic compounds that give us this mouthfeel and color, obviously. And then lots of stuff happens, and then you have this marvelous product called wine. And what I'm really interested in is better understanding all of this lots of stuff, and particularly how much stuff is being contributed by the microorganisms. We know there's a whole bunch of microbes in there. A whole lot of them are doing positive things. Some of them are doing negative things. We want to better understand that process. We want to try and optimize that process. We want to try and give winemakers better tools to kind of manage that whole process so that you're getting, you know, the maximum kind of best flavors and aromas, these phenolic compounds. These microbes will impact all of these different aspects of the wine to different degrees. When we talk about wine microbiology, it really is a jungle in there. There's a whole lot going on. If you're familiar with any other food processes involving microbes, winemaking is a little bit different. For example, beer or cheese production, there's often a heating step, pasteurizing the milk, where you eliminate most of the, if not all of the organisms in that product, and then you might inoculate in an organism to do the ferment to produce the cheese, to produce the beer. So beer, you heat up the wort before you are fermenting it. In winemaking, there's not really that whole pasteurization step. Yes, there's some products such as sulfur oxide you might add a little bit to that kind of knock back these populations, but really you've still got a whole lot of microbes in there to start with and a whole lot of stuff going on versus a lot of other industries, products, sorry. So we are lucky, or I guess fortuitous, that grape juice and wine is a pretty harsh environment, and so only a few of these guys can actually grow in wine and grow in grape juice. One of the things to remember is really there's no pathogens can grow in wine, and that's a big advantage in the wine industry in that we don't have to worry about pathogens and things like that in wine making you sick. You might get sick from some other side effects of wine, but not from E. coli and not from salmonella. So those organisms actually, they're just not tolerant enough to the pH, they're not tolerant enough to the ethanol, and so salmonella, E. coli, all of these nasties that you hear about on TV, they're not going to live in wine, and so we not have to worry about that from a production point of view. Where we're worried about it is from a spoilage point of view. Some of the microbes that grow in wine can spoil the wine, but they're not going to be pathogenic. So you can stomp all you like with your feet. This is not going to cause any pathogens to be in that wine or juice, because most of them will be killed off. That's if you've got pathogens on your feet. I'm hoping you don't. What really interests me as far as microbes and winemaking is because you've got all of these microbes in there to start with, there's all sorts of interactions going on there. There's all these different yeast, there's all these different bacteria, and it becomes a bit of survival of the fittest. Which ones survive? Which ones dominate? What do they contribute to the wine? Is it a beneficial product? Is it beneficial aromas? Is it detrimental? Is it going to spoil your wine? And understanding how these organisms all interact together, because they don't all get along. So the dominance is often dependent on the grapes, the conditions of the grapes. For example, in years where there's a lot of rot on the grapes and they come into the winery, there's a whole different population of organisms in that wine now than there would be if you're using clean grapes. So that can really affect things. Tolerance to inhibitory compounds, in particular we're talking sulfur oxide. That's the major antimicrobial that you can add to wine, really one of the few things. And we try and minimize how much we use that, but we still use it because it's really our best tool to control these spoilage organisms. And then finally, microbial interactions. Do they all get along? And the answer is some of them do, and that's great, and some of them don't. And understanding whether or not they do get along or don't get along can really influence the quality of the wine that we're making. So as a winemaker, what you're trying to do is you're trying to encourage the good guys. Those are the ones that are going to ferment the wine and produce all these lovely flavors and aromas. And you want to discourage the bad guys. We've got some examples in a second here of a couple of wines where some of the bad guys have maybe been active. And you may have smelt wines like this before, and I'll tell you a little bit about why they smell like they do. So the good guys, the first of the good guys is probably a yeast you're well familiar with if you know anything about fermentation or beer production, for example. Saccharomyces cerevisiae is kind of the workhorse of the fermentation world. It's used for all sorts of things. It's used in the pharmaceutical industry even, all the way through to bread making and beer making and obviously wine making. There's different strains of Saccharomyces. There's different species involved as well. And they all do some things a little bit differently. And so the winemaker has a catalog with maybe 200 different strains of yeast that they can choose from. How much difference they make in the whole course of the winemaking is a little bit debatable. Some of them have some mild changes to the wine. Some of them may be a little more dramatic. But those are the yeasts that are primarily taking all of the sugars in the grapes, the glucose and the fructose, and converting it through to ethanol. So that's really that's the major thing we want the yeast to do. If they do nothing else, they've got to take the sugars, convert it all the way through to ethanol. But they also do some side effects, some other things that we like as well. They produce some flavors and aroma compounds, things like esters, for example, fruity aromas. They can be quite important in a white wine in particular. And so they do produce some compounds there that we like. But primarily what we're interested in our yeast doing is taking that sugar and fermenting it all the way through. If the yeast can't do that, it's not much good to us. The other good guy in this story is a bacteria, and this is a fermentation that maybe you're not as familiar with. It's called the malolactic fermentation, and this is a fermentation. It's not really a fermentation, but it's a conversion of an acid, malic acid, to lactic acid. And this bacteria is able to take the malic acid in wine and convert it through to lactic. Malic acid is very acidic acid. It's very sharp. Has anybody ever bitten into into an unripe apple? How about Sour Patch Kids? You had one of those? A lot of candies, sour candies, have a lot of malic acid in them, and unripe apples have high content of malic acid. That's that acid, and sometimes can be a lot of it in red wines, particularly in cool years. So 2010 and this year, malic acid levels are very high in the Pinot Noir grapes, and so the wines that we're making are initially quite high in acid, can be pretty acidic and not very appealing. So what you do is you take these bacteria, you inoculate them into your wine, they convert this acid to lactic acid, which is a much softer acid, and so it really decreases the acidity in the wine. And so for red wines, particularly in a cool climate, malolactic fermentation is almost always undertaken. There's some white wines that also undergo this process, most commonly Chardonnay. And this is the style of Chardonnay, more the California style, where it's barrel fermented, barrel aged. There's some oakiness, some butteriness to it. That's often undergoes this process as well. I showed this picture before of these little, sorry, this pointer's running out of juice, of these little guys here. They're actually very, very, very little. This here is a yeast, and these little guys here are the bacteria, so they're kind of dwarfed by the yeast, and they don't always get along. And some of the research that I've done in the past, looking at these organisms, trying to figure out which yeast and bacteria get along so these processes happen in a timely manner. But those are the good guys, the main good guys that we're interested in, and we do a bit of research trying to understand these yeast. There's a process, I mentioned the yeast back here, the Saccharomyces. You can buy these commercial yeast if you've ever done any brewing or winemaking. You know that there's yeast available. You can just go to a catalog and buy them. But the traditional way of making wine is to let the yeast naturally present on the grapes do the ferment. And there's a lot of wineries in Oregon. I shouldn't say a lot. There's a higher proportion of wineries in Oregon that do this, letting the natural yeast do the fermentation, and that's called. It goes by. People use different names to call the fermentation process, either wild fermentation or indigenous fermentation or a native fermentation. Basically, letting the yeast that are coming in on the grapes or in the winery do the ferments. There's a lot of interest in doing that. It's kind of more of an old world way to make wine. It's felt there's maybe some better diversity in flavors and aromas versus using a commercial yeast. It's kind of still debatable whether it does make a large difference or not, but it's kind of a stylistic thing that people still do. But we have a couple of projects, research projects, really trying to understand what yeast are coming in from the vineyard. Are they that different than the commercial yeast, and do they make a difference to the flavor and aromas of the wines? Is there a beneficial thing that's going on there when you're using these native yeast? All right, that's the good guys. Now the bad guys. I talk a lot about the bad guys to winemakers, and I make people try a lot of bad wines. Hopefully to reinforce that you don't ever want your wine to go like this, because they can do some pretty interesting things in your wine. Interesting is a good term to use if you're not sure what else to use. Just say the wine's interesting. This guy here, Brettanomyces, is probably the biggest spoilage problem in the wine industry. There are other organisms that can do a lot of damage, but they're easier to control, they're easier to look after, easier to prevent. This guy here, Brettanomyces, is really tough. It's pretty resistant to SO2, which is really our only tool to control it. It's a real good scavenger of all sorts of different sugars and carbohydrates and things in the wine that the other yeast can't use. So it's kind of lies in wait and waits for everything else to do its thing, and then it can pop up in the wine. So it can utilize a whole range of different substrates, so it's a pretty good adapter. It actually originally came from, the name Brettanomyces comes from British brewing fungus is what that means. And so it was actually Brettanomyces was used to make beer, still is used to make certain styles of beer or a part of that process. And that's where they first kind of isolated it from. But in wine, we generally do not want it. It tends to produce compounds in wine that smells like Band-Aids, that smells like a horse barn, a stable, that can get pretty nasty, fecal even. On the more positive side, I guess, can produce some compounds that are a little more smoky or leathery. And this is also one, if you're familiar with Pinot Noir and different styles of Pinot Noir from around the world, that certain areas of Pinot Noir production often have some of this taint, I'll call it a taint, some of this flavor, aroma in their wine. It's one of those ones where some people like a little bit of it in a wine, but not too much. And so if you've ever had a wine that smells a little Band-Aidy, a little like a horse stable, this is likely the culprit. But it is one where there's a bit of a balance there, that low amounts of it in some wines actually people feel can enhance a wine. But often case it goes too far, and then it's, no one really wants their wine smelling like a Band-Aid. The last group of bad guys are bacteria, and there's a few of those, and we've got some studies looking at these guys. There's some interesting names: Lactobacillus, Pediococcus, Acetobacter. This one falls under a class we call acetic acid bacteria, and they obviously produce acetic acid. So if you're making vinegar, that's kind of cool, but if you're not, then you don't want these in the process. So vinegar producers use some specific types of acetic acid bacteria. They can also infect your wine, and what they do is they convert the alcohol into acetic acid, and pretty soon your wine starts smelling like vinegar. If you don't keep your wine topped, that means if you don't keep your vessels topped right up and exclude air from it, you're likely to have this grow on the top. These guys need oxygen, so they grow on top of the wine. So if you keep your barrel or your carboy or whatever you're making wine in topped right up, that'll help prevent them. But if you don't, if you let it get down lower, then they'll start to grow in your wine, and they're pretty tough to get rid of. Some of the smells associated with this bacteria: nail polish remover, that's a compound called ethyl acetate. It's very pungent. It's not a very pleasant smell. Obviously vinegar. Butter is another one. There's a compound diacetyl that's basically like movie butter popcorn. That's diacetyl they put in that. And some styles of wine actually can deliberately would like a little bit of diacetyl in them, so they use bacteria that produce diacetyl. So those big buttery oaky Chardonnays, that butteriness is coming from this compound. But in other types of wine, you don't really want your Pinot Noir having this buttery overtone. It's not a desirable characteristic. And lastly, you can have it smell a little mousy, and that's not a very good thing to have your wine smell like. This poor little guy down here. There's some compounds that will make the wine smell really mousy. I know it's all doom and gloom here, but these are some things that do happen. I have smelt wines that do smell mousy. It's not a pleasant thing, and not something you want to put in your mouth. So, what do you do to prevent this stuff happening? And both from a commercial sense and a small winemaking, home winemaking sense, there are a few things you can do. I just wanted to give you a couple of little take-homes if you're trying this at home. The biggest thing is cleaning and sanitizing thoroughly. I think both for winemakers on a big scale and winemakers on a small scale. As soon as you slack off on cleaning and sanitizing, that's when you have problems. Often it's actually harder to be thorough and clean and sanitize when you're making wine at home that it is in a commercial winery. But that's the biggest thing. It might sound simple, but that's where often your problems come in, is when you're not using things that have been cleaned and sanitized properly. Adequate levels of SO2 come along with that. That is our really only defense against these microbes, to kind of keep them at bay. In a commercial winery, they have very good ways to measure this compound, and at home you most likely don't. So often this gets neglected. Maybe you knew you put some in a while ago, but you really don't know what's there. So the problem is you add too much of this compound, and it can be you can smell it. It's a little harsh on the nose. Some people are also allergic to SO2, have some allergies with it, so you do have to be careful with it. And it is, like I said, kind of difficult for the home or the hobby winemakers to keep track of. The other biggest issue, and this is more for small-scale winemaking, and even the research wine we're doing, we're classing ourselves as small winemakers, is oxidation. And that's a really hard thing to control on a small scale, because if you think about a winery with these huge tanks and they've got a little bit of air on them, the volume of air to wine is very, very different than if you've got a carboy and you have a couple of inches of air on that top. So in small winemaking, you have a much greater chance of having oxidation issues. So keeping things topped and keeping air off them is actually much harder at the hobbyist level. Particularly for whites, whites tend to oxidize quite easily compared to reds. There's these phenolic compounds in reds that tend to be antioxidants, basically, so they can kind of help consume some of the downstream effects of oxidation, whereas white wine really doesn't have a lot of that protection. And so whites will much more easily be oxidized than reds, and you'll notice it earlier in a white too. Your white will start looking brown, whereas your red wine, you don't notice it quite as early. Reds tend to color-wise turn a little brickish orange over time, but they'll also start losing some of their aromas, start kind of smelling a little bit different. So that's the other issue. And then temperature control. This is all about controlling, getting the good guys to grow well, and then preventing the bad guys growing once they're finished. So a lot of times as hobby winemakers, you may not have the ability to warm ferments, and you may not have the ability to cool them when you want them. You're either in one end or the other. Everything's too warm or everything's too cold. In Oregon, it tends to be that everything's too cold. And so getting ferments finished, if it's too cold, can be a problem. Whereas if you have things too warm and you keep storing them too warm, then other things like to grow there as well, and all these spoilage organisms kind of start doing some damage. So keeping it warm through ferment, and then once it's finished, keeping it cool below 55 degrees Fahrenheit if possible, that's going to help slow down some of these spoilage organisms and give you a better shot at making some decent wine. So I think have we got any of the samples going out yet? A real treat for you tonight. So I think there's a couple of. Are they going out in sets of A and B? Take a sniff, appreciate the aromas, come up with some descriptors, and then pass it along. And then I'll talk about what they are. You may have smelt some of these things before. If you're not smelling anything, that's fine too. The things that you're smelling here, people have different thresholds too. Some people are very sensitive to them. Some people may not smell them at all. I wish I didn't smell some of them sometimes, but there are some threshold differences for these particular compounds in the wine. Just smell them, don't drink them. I don't think you're going to be tempted to drink them, but just in case. And while they're going around, I can answer any questions. Yes? Yes.
That's solely due to the introduction of the SO2?
It is due to the SO2, not necessarily just the introduction. The yeast that do the ferment also produce SO2. And so even if you're an organic winemaker and you don't add SO2, there's still going to be some small amount of SO2 in the wine, because the yeast, as a natural part of their growing, produce some of it. Now, they don't maybe produce as much as would be in there if you added SO2. Typically, yeast would maybe produce less than 30 milligrams per liter, and in a wine where it's been added, like a red wine, your total is probably going to be more like 50 to 80 milligrams per liter of SO2. So there's less, but it's still there. Any questions? Do you have a? Take a sniff. There's a question over here. Not so much more prevalent. I think it's more problematic. The question was why I said maybe that oxidation is more of an issue with white wines than red wines. I think it's more obvious in white wines. It happens more easily. Red wines do have that phenolic compounds in them that act as antioxidants. Pinot Noir has less of that, so it's maybe more susceptible to oxidation or changes due to oxidation. When you think about aging red wines, you're actually getting slow oxidation occurring during that whole time period. And that's actually helping the red wine age and develop. White wines, it's usually, except in some styles, it's usually more detrimental. A lot of the aroma compounds are very sensitive to being oxidized, and so that can really damage the aroma. Yes, Christian.
Chemistry question. Some organism
Yes. You can measure pH change, yes. It depends. Obviously, it depends how much malic is in there, but you can get a 0.2, a 0.5 pH change. Remember, that's a log scale with pH, so it can be quite dramatic. And actually, what we saw last year, 2010, and we'll see again this year, is that even though the grapes come in very acidic, they drop that malic out so much during malolactic fermentation that the pHs don't become as much of an issue. In fact, some winemakers who